Hello, my name is Nikolaos Papakonstantinou and I work at the VTT Technical Research Center. And I'm here to talk about something a little bit different than what you have been listening so far. So I think that the maybe common theme of the presentations until now, it was using OPC UA to talk to machines from a higher level, or how can machines talk between themselves if they are from different vendors. But the OPC UA meta model is much more flexible. It doesn't always have to do with communication to machines or between machines. It can also model other kinds of information that is relevant to the factory. So in this presentation, I will talk about using the OPC UA meta model to transfer information from the design of a plant. So in more detail, transfer piping and instrumentation diagram information, so the basic layout of the plant using OPC UA. So as in the automation world, between different machines, there is the big problem of interoperability and how do machines talk to each other. There's a similar problem in the computer-aided engineering world, in the how plants are designed. So different drawing tools, they cannot interoperate with each other very well. If you have made a design in one tool, let's say used AutoCAD, it's not very certain that you can transfer it perfectly to another vendor, Bentley or Aviva or whatever else. And that's a big issue. So I will talk a little bit about the challenges. I will talk about some standards and some technologies that are relevant to this. Then I will briefly mention some information about the DEXPI group and how we have started an effort, a working group under the OPC Foundation to make an OPC UA companion specification for piping instrumentation data using the DEXPI specification. And then I will be talking about the progress that we have done so far in this working group. The slides have more information than what I will be talking about, so you can download them if you want to see some links and more information. I will go a little bit faster now. So what's the challenge here? Why do we need to have this kind of interoperability between tools? Isn't a company that works with, let's say, Siemens happy to always work with Siemens? There are issues when they are extending their businesses to different areas. They are using different tools. There are issues in subcontracting when you want to get some diagrams built by someone else who doesn't use the same platform. So big businesses big industries have realized that it's not the optimum way to have isolated vendor-specific tool chains and not be able to move data from one vendor to another. Of course, this kind of lack of common access to this information restricts the use of this data for more services. So it's not easy to build some kind of service when you have to talk different language to different data source. If you want to access, let's say, data from Siemens or from Bentley or from ABB, you have to use a different API, a different database, a different way to attach to this data. A relevant standard, especially for the piping instrumentation information, is the ISO 15926. So it wants to promote a standard way of integrating life cycle information of processes, and it has come from the oil and gas industry, but it can be applied in all kinds of industries. It is promoted by the POSI CSAR organization. Another relevant technologies is the Proteus schema. So the Proteus schema gives us a way to store piping instrumentation information. It started its life called XMPlant, but now after the Proteus FIATEC project, the name has changed into Proteus, and it is the schema that supports the ISO 15926. So the ISO 15926 is a more generic specification, and then the Proteus is the XML way to transfer the data. So the DEXPI group, it's a group under the DEHEMA umbrella, and it's a group of vendors, software vendors, industries, and research partners that they try to build this standard for interoperability between different tools that can be used to draw piping and instrumentation diagrams. It has some very strong members from owner-operators side, from the computer-aided engineering software vendors, and also research partners and so on. And the key here is that these companies are big enough to be able to work with the biggest, most major vendors in this domain. And they actively try to build this DEXPI specification for exchanging information. It's not so then that it's a group that will build a standard and then companies will come and then software will be built to support this. They start from a practical point of view. So the product so far, it's an ongoing effort, and the most current version of the specification is the 1.2 version. And as I mentioned earlier, they have a very strong opinion that this should realize. There is no way that this will not happen. They have regular management meetings where the top brass, let's say, of the owner-operators gets to check the progress of the DEXPI group. The DEXPI group itself meets almost every month in Frankfurt, and then there are additionally hackathon events where owner-operators and software vendors can meet up and do some debugging and check what's the progress of every software vendor in implementing the Proteus as one standard export-import of their tools. There is a set of test cases. Basically, there are like little P&ID drawings that are used to check the progress and help the different vendors work with each other. And also, these are openly, publicly available in a GitHub repository. So, what is the motivation? Why would we like to have such information offered to us over OPC UA? It's not relevant to devices and automation. But is it? It's an information source about the plant. And we have to think a little bit out of the box. What can we do if we have this kind of information in addition to information we get from the floor of a plant? And also, what happens if we have also other sources of information coming up too that are relevant to the plant? And we use this common language to talk to all of this. So we can have simulations running in the background. We can have historical data. We can have real-time operational data. We can have design, all kinds of design data. We can have maintenance data. We can have data coming from the clients. We can have data coming from the engineers on the floor. So if we have this, what kind of services can we build on top of that? How can we use this kind of information for something extra, additional, that someone would be interested into and say that Industry 4.0 really gives me something more than just doing things that I was always doing, but in a little bit different way. So a year ago, we have done some kind of research on top of that, and we have been experimenting how it would look like if we could just select something from a plant in the 3D model of the plant and then be able to access all kinds of information. In this case, it was simulation, design, and automation, real-time automation data, using a common interface. We didn't go to that point to start building more complex queries that combine multiple sources of information, but this is the next step that we need to do. So it is important to be able to see OPC UA as a way to access also other kinds of information other than just machine automation data from the machines of the plant. In that context, we started an OPC Foundation working group to build an OPC UA companion specification that will describe how piping and instrumentation information, which follow the DEXPI specification, can be expressed as OPC UA node sets, which can then be used to offer them using OPC UA servers. This is a joint effort between the OPC Foundation and the DEXPI group. It has already started in April. We already had 4 working group meetings. And we have a very good idea how we move forward. There is a nice UML representation of the DEXPI specification, and we are now building the tools to do the mappings to the OPC UA data model. Here is a little overview of what we are trying to do. Everything starts from the drawing tool that exports a Proteus, so the piping and instrumentation drawing tool. You can use here Bentley or Aviva, which produces a Proteus XML file that follows the DEXPI specification. Then this is converted into the pure DEXPI classes that follow the UML meta model of the DEXPI. And then our tool can generate the node set that corresponds to the items in the P&ID diagram. And of course, the types, the OPC UA object types, are transferred from the UML representation of the DEXPI meta model. So, for example, we have a class that is called actuation valve. So we create an OPC UA object type that is actuation valve object type. And then if we see here that there are three actuation valves in the P&ID diagram, we create here 3 actuation valve objects that then they are typed as actuation valve object type. So far our progress is that we have created a draft set of the object types that correspond to the DEXPI specification. And the next step is to work more on this draft set of object types and also do the real diagram transfer. Here is a little snippet of how the DEXPI specification looks like in UML. So you see all the different equipment types, axial compressor, agitator, nozzle. So it's all the equipments that are supported by the DEXPI specification. And we run this XMI, so it's the UML as it looks like in a file, XML file format. We run it in a tool, and we can get the node set corresponding to these classes. So it has all the object types that we want to use. And here is how this node set looks like in a tool that you might be familiar with, UA Modeler. We have transferred there all the attributes and so on that are in the UML model. So the question here is that I would like you to open up your mind and think that if we have this kind of additional data sources, how would they help you in your workflow in order to make things more efficient, to provide additional services? As VTT as a research organization is not here to sell products, final solutions, but it's here to help research and help companies invest more in their tools and innovate. Thank you.
So questions or answers to the question.
Is the generated node set like specific for each like drawing? There is like no actual like common node set for like general drawings, or is it like always like specific to that one drawing?
The way it is implemented now, we are doing this prototype implementation, and it's one node set that has all the object types and then has the specific part for the diagram. That's our goal now. I suppose that there are ways to have the object types in a separate node set that is static. We don't have to generate it all the time, and then the specific node set that has the real objects separately.
I would highly recommend to do that.
Yeah, that's the way.
Because then it's common namespace for like the types, and the instances are in different namespaces.
Yes, definitely that's the best way to go. Now our focus is to work on the mappings and how these object types really look like, and not so much into exactly how the final version will be. But that's a very good point. Thank you.
Thank you. Question from my side is, you mentioned about ISO, gas and oil industry in this case. Yeah. I also know from the IEC side that they are working or still finished properties for all the different components inside gas and oil industry, for transmitters, for temperature measurements, and all these other things like in the P&ID included. Do you use these properties, or do you build up new information models with different properties from the IEC?
I think that you will have to refer to the DEXPI group, and maybe you want to check their specification. I'm not really sure. I know that they are trying to coexist with other specifications and not do the same kind of work, but I'm not sure.
That's the question, because I have not seen in your presentation IEC standards, so yeah. 61360 is the basic standard, and then 61987. Yeah. These are different specifications with information models inside for all the products which is used in process industry.
Right. If you could send me an email or contact me, then I will get you in contact with some people from the DEXPI group who can reply or even take into account this. Thank you.
More questions? Comments? Okay, yeah, but this one of the latest working groups. I'm actually also working with Nikos in the working group, and we are trying to ensure that it fits in place with the OPC companion specifications. There's also related work that we've heard that someone tries to also start a group, or I think it's maybe already started, where they try to work on a standard model for all industries, because we have here concepts like equipment, for example, which DEXPI is defining equipment in one way, but equipment is defined also in ISO 95 and maybe in other information models, but they are defining a little bit different aspects of the equipment in each model, and then the question is that what is the standard model for an equipment? But then we come to the thing that OPC UA and OPC Foundation cannot really solve the overlapping of the different information models or the how they interact with each other. But VDMA that we mentioned is going to also take a look at the overlapping models, and then we have maybe other initiatives which try to combine the existing information models that are coming from different sources and bring higher level models to work on. But this ISO 15926 should also be already kind of a standard model. But the practical problem will be that there are already different models that have been brought up from different organizations, and they are really defining similar things but in a little bit different ways, and that will create another level of problem of another level in future. But I think that's already huge progress that we get these models, and we can think how they are used together or with each other and so on. But first thing is that we have the information. The next level is we try to figure out how to use those in all different ways. Okay, thank you, Nikos. We managed to catch up a little bit while now we are at the point where we are having coffee, and I suggest that we continue Q2 3, and after that we have plenty of nice presentations coming up, and we have one more break during the afternoon after that. But now we have the coffee, and enjoy the discussions.